Hi, this video is going to cover section 6.2 for integrated course 1, and this one is over central tendencies and dispersion. So first of all, let's talk about what central tendencies are. All they are ways to find the central or the middle. So when you're asked for the central tendencies, we have three ways to find the middle that you've been doing for years. So the first one's the mean. Okay, so the mean is a lot of times referred to as the average, but the mean, median, mode are all ways to find the middle or the average. So that's kind of a tricky term. But average, when I say I'm averaging your grades, I mean the mean. So that's typically the word we see. That's where you add up all of your data and you divide by the number of data that you were given. The thing you have to be careful with the mean that I noted here at the end is an outlier will throw off your mean. What I mean by that is if we thought about, like, I don't know, the income in Idaho, and we included some really rich billionaire who happened to live in Sun Valley, their data would make everyone else's incomes look high because he would have such a high outlier compared to everyone else. So mean is a great way to find the average if you do not have an outlier. Median. So the median is another central tendency. And remember, this is the middle number. So you got to put your data all in order, and you got to find that exact middle number. Only if you have an odd number of data points, right? If you have that even number, so you have 10 numbers or 12 or something, then you take the average or the mean of the two middle numbers. And that's just how we find that. The median is a much better choice to find the average or the middle if you have an outlier, because the median doesn't, the outlier is just another number. It's not so much bigger or so much smaller. Okay, mode. Mode is the most common number in your data set, or your data set doesn't have to be numbers necessarily. So mode is used when, let's say, you're collecting everyone's favorite color, right? What's the average color? You can't add those up and divide. You can't put them in an order and circle the middle because you can't. What's better, orange or purple? You can't do that for colors. So the mode is used when your data is non-numerical, not numbers. It's also used, maybe you want the most popular. It's a good time to use the mode. I use the mode a lot for grades and the median better than I do a mean when I'm trying to tell parents how students are doing in my class. So mode is a great one. Well, most people, popular, got this grade. So that's kind of a good way to use the mode. And I defined an outlier. It's just a number that's a lot bigger, a lot smaller than any other number. So you should know what an outlier is and what I'm talking about. So let's say we're talking grades. And one person got a 99% and everybody else was in a C range. I would say that's an outlier for that one person that got that really high grade, okay? Could go the other way. Maybe one person got a 5% and everybody else was a C or above. That one would be an outlier. Okay, then we started talking about this measure of dispersion. Okay, so a measure of dispersion is just how spread out your data is. How disperse is your data? The range is one way to measure the dispersion. We are going to learn other ways as well, but the range is just the difference between the highest and the lowest numbers. You just subtract them. Difference, subtraction, right? So range, you just subtract those two numbers. And then I wanted to remind you of what a line plot is. Now I could use dots or I could use little X's like this. Your book likes the X's, so either way. So a line plot or a dot plot is what it's sometimes called in other textbooks, is just a number line with marks for each data set. Okay, and I'll do another one in a minute, but if I have numbers like 1, 2, 3, 4, 5, and I have 1, 2, and maybe I have 4 3s in my data set, 1, 4, and 2 5s, this is what a dot plot or a line plot would be. Kind of similar to that frequency table that we did in the last one, except you don't have an interval. You put a dot or a little X for every single number. And your number line has to count in order. You can't go 2, 3, 7, 12, 22. No, it has to count in order. You can count by fives and then just, put tick marks or something like that and but you have to count each number. Okay, so my first example of using this central tendencies or the idea of dispersion is going to be kind of a big set of numbers. So, oh, maybe I'll just show. I don't want to show the answers though. Let me cover up part of that. Oh, let's write them out again. Okay, so here are my numbers for the first example. This is one of the examples straight out of the book. So 21, 22, 19, 20, 23, 21, 20, 24, 20, 19. 20, 21, 21, 23, 21, 22, 19, 21, 19, 20. So kind of a lot of data. And I did that on purpose because, I could give you one with two, short, and it just I'd rather do a couple harder ones and then do a couple easier ones. Okay, so lots of numbers here. And I want to find the mean first. So what I'm going to have to do is add up all these numbers. You could just get out your calculator and you could add those up. Or another thing you could do is use Excel. So, oops, I want to delete that off because I was just making sure I could do it. So in Excel, I could type in all the numbers, and then at the bottom here, I could make it add up all my numbers for me. Okay, so I could say, okay, you use an equal sign, or you can hit this little f of x, and we want the sum. Remember, sum means add, and I push OK. And then it goes through all of this part of A1 through A20, and that happens to be, if you want to make sure this is right, you just make sure it goes through the right numbers. If you do it right under, it always does the right ones. Okay. Another way you could have done that same thing is hit equal sign and then the word sum and then use a parenthesis, and then you could just highlight them and end your parenthesis and hit enter. So you can see the sum here is 416. I like using equals, writing in my own sum and highlighting it. But either way, you could use the function keys if you want. But we can see that they add up to 416, and I'm going to delete that off afterward. So we could easily use Excel to add things. You could use your calculator as well, no problem. Probably just want to do it twice just to make sure you got the right number. So for the mean, we're adding them all up, and we got 416, and we need to divide that by the number of data points that we had. And the number of data that we had in this one was 20. Okay, so there were 20 different data points in that problem. So we divide that out, and we can get our mean as 20.8. Okay, now for the median, you have to put them all in order, and there's 20 of them, which is fine. You could do that. Or you could use, again, Excel, and you could, I am going to highlight my numbers, and I'm going to go to sort, and I'm going to sort from smallest to largest, and there they are. They're sorted. Now they go in order, so we know at 10, there's 20 of them, right? So 10 and 11 are the two middle numbers. So we add those up and divide by 2 for our median. And that's going to be 42, and then divide it by half, which would give you 21. Doesn't it make sense that the average of 21 and 21 is 21? So if they're the same, of course their average is going to be the same. Now that it's in order, though, that does make the mode easy. So the mode is the most common one. So if you look on here, you can see that there's 1, 2, 3, 4, 5, 6 21s, and there's 5 and 4, so there's 6 21s. So 21's our mode. Now remember, sometimes you don't have a mode, so sometimes the numbers don't repeat, and sometimes there's like 2 modes, and that's okay. Once there starts to be 3, 4, 5 modes, that's kind of silly. You could list them, but it starts to be a little bit ridiculous. I usually go with no real significant mode, something like that. Or no mode. So here we are. These are our 3 averages. Oops, let me move this out of the way. So these are our 3 averages here. We have our mean, our median, and our mode. And then let's talk about that range or that dispersion. How far spread out are our data? So we could find the range by the highest number. subtract the lowest. Well, our highest number was 24 and our lowest number was 19. So our range is only going to be 5. That is super low, right? So our range of numbers, there's only 5 different numbers that are showing up, or the range of numbers is between 5 numbers. Um, Another thing we could do with this data is we could easily make a dot plot with it. And you could start with whatever number. So I'm going to start with 19, and then you have to count 20, 21, 22, 23, 24. And we know that there were what? Let me look over at my little Excel thing that's in order. There were 4 19s. So I would go 1, 2, 3, 4. And you try to make them even as you can. And then 20s, there were 5. 1, 2, 3, 4. So it should be 5 about equal so you can tell. And then 21, there were 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 21 should look taller than 20. Probably should have used a little better thing than I did, but that's okay. 22, there's 2. And 23, there's 2. And 24, there's 1. So this kind of shows you your dispersion as well, that dot plot, because then you could see a lot more of the numbers right in here, a lot less of the numbers this way, kind of thing. No real outlier, because 25 is not, or 24 is really not that far off 23. Now, if I would have had a 50 way over here, then that would have been an outlier. And so that's kind of looking at that data set. We could make a histogram of it as well and see if it's skewed or any of the other things we learned in the last section. But that's all I want to focus on for that problem. Let's look at a problem, or 2 different little sets of data here. If I have 1, 29, 33, 31, 30, and 33, and then set B has 8.2, 9.3, 8.5, 8.8, and 9.0. So I have 2 different sets of data here. And I want to know what you should use for set A and set B, mean, median, or mode. So you should be able to look at this data and tell me which central tendency is the best choice. So let's look at set A. We have the number 1, and then it goes 29, 33, 31, 30. So these are all around 30, and the number 1. So 1, I would say, is an outlier. So what should we not use if we have an outlier? We should not use the mean. It's going to be way lower average because that 1 is going to pull our average down. So we're going to use the median. Can we use the mode? There's 2 33s. You could use the mode, but really it's usually between the mean and the median. The mode is only a good choice if you're looking for popular or if your data is not numbers. Look at set B. All the numbers are similar. There's no outliers, so we can use the mean. We really could use the mean or the median, but the mean, we could use that one. That's kind of the way the book explained it a little bit, but I wanted to make sure you really could use, well, you can't use the mode on this one because there isn't one. Yeah, the mean. So you're stuck with the mean. That's what I was thinking, is you could possibly use the mean. Another problem that we see often that people struggle with is, and this is why I won't give this information to you. Let's say you got the following grades: 87, you got a 95, you have an 86, and an 88 on all of your tests in your math class. And you want an average of a 90 so you can get the A in the class. What is the minimum grade you have to get on the last test in order to average of a 90? So you want that A. I get asked this all the time for the final exam, except you got to be careful because the finals were 20%. And anyway, so what would I do? Well, we know that we would add up all of these plus the test that we have to still take and divide by the number of tests. So we would think of it as we would have to take 87 plus 95 plus 86 plus our 88 plus what we don't know, which would be our new average. And we'd have to divide that by 1, 2, 3, 4, 5. and we would like that answer to be 90. So that's kind of how you set it up. I'm going to sneak out my calculator because I don't want to add all of those in my head. So I'm going to go 87 plus 95 plus 86 plus 88 is going to give me 356. So I'm going to solve this. I have 356 plus x over 5 equals 90. Times that 5 over to the 90 because it's division now, so we got to times it over to get rid of it, and that's going to give me 450. So I'm going to have 356 plus x equals 450. Now subtract that 450 over, 356 to the 450, and I get 94. So you would need a 94 on your next test in order for you to receive the grade that you want. And that's pretty much all they're asking in this section is a couple questions like this one where you kind of work backward that try to make you think more about the reasoning of a mean and how you're finding it. And then it gives you some other real life questions on mean, median, mode and when to use what. And that should be, they have that one here. So I'm going to just show you this real quick. I didn't see it in the directions, but maybe they assume you know how to do it or know what this is. So this is a stem and leaf plot, and this one's actually a double stem and leaf plot, and they give you the directions here. So this is like 43, 45, 49. Here, this is like 58 on this side for the A. It's a 58, 57, 54, and so forth. And then this side, it's 52 or 57. So you read those numbers together. It's kind of a shorthand way of writing numbers. It's called a stem and leaf plot. It looks like they give you some of the problems in that format. So don't make that harder than it is. Oh, but they want a dot between these ones. I have not seen that in a long time. So instead of 43, it's 4.3. So I guess I should look at their key. So typically you won't see it with the dot. Typically you'll see it as a bigger number. But I'll show you that. Otherwise, this is about it for 6.2 is mean, median, mode, and your range.